All right. So I'm assuming most of y'all have no idea what to do.
Yes.
So what we're going to do is I'm going to work a few of the problems to show you what to do for your homework. So number 2, that's what we're going to start with. Then we're going to do 4 and a couple more on the back. For number 2, the first thing you should ask is what do you start with and what do you have? So here it says determine the frequency, which is V, of light with a wavelength of this number right here. So I have frequency and wavelength. The only equation that has frequency and wavelength is this one. C is equal to the wavelength times the frequency. So C is equal to the wavelength times the frequency. They want to know determine the frequency, so I need to figure out what V is. So the only way to do that is I need to divide by my wavelength. Wavelength will cancel out there, and so I'll have C divided by wavelength is equal to V. And so from there, I can just plug in my numbers. C, I know it's from the periodic table. Let's take one out. And C is here. Speed of light, C is equal to 2.998 times 10 to the 8th meters divided by seconds. So let's put that. 2.998 times 10 to the 8th meters divided by seconds. And then I need to divide by the wavelength. So let's set up a table. Since I am dividing by the wavelength, I'm going to put the wavelength at the bottom. Okay, divide by the wavelength, it goes at the bottom then. So 4.257 times 10 to the negative 7 centimeters. And there we go. Okay. So they are trying to figure out what frequency is. Frequency is 1 over S. Remember, I just have to change it to 1 over S. So the only unit I want to keep in this equation is the S, so I need to get rid of meters and centimeters. To get rid of both of those, to get rid of meters, I need to put it at the bottom, so meters goes here. To get rid of centimeters, I put it at the top, centimeters. 1 meter is 100 centimeters. And then I can calculate. So in this problem, it'll be 2.998 e to the 8 divided by 4.257 e to the negative 7 times 100. And I get in 4 significant figures because this number right here is 4 sig figs. 7.04. The 2 is going to round up to a 3, so 3. And then it says E16 at the end, so times 10 to the 16. Canceling out my units, I'm left with seconds in the denominator, so 1 over seconds or hertz. Okay, cool. Number 4. This one says, what is the frequency if I have this much energy? So this one has energy and frequency. Those are the 2 things that are listed in the problem. So looking here, energy and frequency all in one equation. So I'm using this one, equation number 2, E equals HV. So E equals HV. They want to know frequency. So I need to solve for V then. The only way to solve for V and get it by itself is to divide by H. And so E divided by H is equal to V. And so here's my equation that I'm going to use. So I'm going to plug in E, which is this number, and I'm going to divide it by H, which is Planck's constant. E is 9.33 times 10 to the negative 4 kilojoules divided by mole. Divided by H, so H is going to go at the bottom right here. If I look in my periodic table, here's Planck's constant, H, 6.626 times 10 to the negative 34 joules per second. 6.626 times 10 to the negative 34 joules times seconds. Okay. So here, nothing cancels out, so that's not good. They want to know what the frequency is, so it's going to be 1 over S, right? So I need to somehow just get 1 over S. Here's my S, so it's already in the denominator, but I need to get rid of joules, kilojoules, and mole, all in this problem. So to do that, let's do the first one. Get rid of kilojoules. To get rid of this, I'm going to put it at the bottom. To get rid of joules, I'm going to put it on the top. 1 kilojoule is 1,000 joules. And when I do that, kilojoules cancels out and joules cancels out. Good. Now all I have to get rid of now is mole. To get rid of mole, mole. And on the opposite side of mole, we're going to write photon. 1 always goes with mole, and photon is Avogadro's number, 6.022 times 10 to the 23rd. And then looking here, mole will cancel out. So I have photon left over, but remember, we don't always have to write photon whenever we're writing it. So we have seconds in the denominator, so it is 1 over seconds. And so now I can just calculate it. So 9.33 e to the negative 4 divided by 6.626 e to the negative 34 times 1,000 divided by 6.022 e to the 23rd. Oops. And I get this really long number. Let's just write it in scientific notation. So 3 sig figs, so 2.34 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9 to the 9th power, and that's going to be 1 over seconds or hertz. All right, 2 more. If I can fix this. All right, that's fine. All right, so here we go. Number 7. What is the energy of in kilojoules of a quantum of light with a frequency of 4.31 times 10 to the 14 hertz? So I have frequency and energy. The only equation that has that is E equals hv. So that's the equation I use. They want to know energy, so I'm not going to change the formula. I just keep it. H times V. So H is 6.626 times 10 to the negative 34 joules times seconds divided by V, which is this. I'm sorry, times V, because I'm going to multiply there. So if H is here, V will go also at the top. 4.31 times 10 to the 14. And I'm going to change hertz into 1 over S.
The electron configuration.
All right, just give me a second. 1 over S, seconds cancels out, and so I have joules left over. In this problem, I want kilojoules though, so I need to change joules to kilojoules. To do that, I just do one more step. Joules, kilojoules, 1 kilojoule, 1,000 joules. Done. And then multiply, and then divide by 1,000. Wait, which one?
The electron configuration.
Oh yeah. Just give me a minute. And I get 2 point, I don't know. How many sig figs? 3 sig figs, 2.86 times 10 to the negative 22nd kilojoules. And then this one's a little bit easier. I'll just set this one up and then you can solve it yourself. Here they're asking what is the energy, and I have wavelength here. The only equation that has both of those is E equals hc over wavelength. I don't need to change the formula because I'm looking for energy. So H times C, so 6.626 times 10 to the negative 34 joules times seconds. That's H right there. Next is C multiplied, so 2.998 times 10 to the 8th meters divided by seconds. And then last, divided by the wavelength, so it goes at the bottom. So 413 nanometers. They want energy, so all I really want to keep is joules. So I'm going to get rid of everything else. Seconds goes away. I need to get rid of meters and nanometers. Meters, nanometers. 1 meter is 1 times 10 to the 9 nanometers. And then to do this one, 6.626 e negative 34 times 2.998 e to the 8 divided by 413 times 1. Okay. 1 e to the 9. and I got 4.81 times 10 to the negative 19 joules.